Zero product property. In this video, I'm going to show you how to solve quadratic equations using the zero product property. You're watching this video with Ms.Y Cavazos. So, quadratics, we've been working with them. We've been working with factoring quadratics. Now we're going to solve them. Just like we solved linear equations, now it's time to solve quadratics. So, zero product property says you have a number, let's call it A, times another number, let's call it B, and they give you a 0. Well, how can two numbers multiplying together give you a 0? Well, it can happen if A is 0. So let's say B was some kind of number, 9, 10, 11, whatever you want it to be, times 0, it's going to give you 0. Or it could be that maybe B is 0 and A is some kind of number. Well, any number times 0 will result in 0. And that's what the zero product property is. Product because we're multiplying, 0 because that's what they multiply to be, a 0. So how do we use this in solving quadratics? Now, we've been working with quadratics, and what we've been doing is we've been factoring a quadratic. So here's a quadratic expression. Right now, it's an equation because it's equal to 0. So what we're going to do is we're going to ignore this 0, because that may be confusing you. We've been factoring this, and this is how we factored. We found two factors, two binomial factors, that when you multiply them, they result in this quadratic expression. Now, what's so different about solving quadratics is, of course, it's equal to 0. So that means that when you find your two factors, you simply set them equal to 0. What this allows us to do is, well, this is a linear factor, and we're going to set it equal to 0. Well, if we get to do that to the first linear factor, then we can also do it to the second linear factor. So we can set that equal to 0. All it means is that we're going to isolate the variable x. We have two types of equations now, two linear equations, and these linear equations you've been solving since 7th grade. So you can do this. We would isolate x on both, and then that would give us our solutions. Another word you might hear referring to solutions is zeros. Because, well, that's what makes this equal to 0. Now, let's apply that to quadratic equations. What we're going to do is we're going to find the solutions to each quadratic equation that we're going to have here. To do first is, let's go ahead and cross off that equal to 0, because, it's kind of bothering us, it's confusing us. So I'm going to go ahead and put my parentheses so I understand I'm going to have to factor. So we're trying to find the factors of 18. Now, some of you might have done this X deal that would help us to find the factors of 18 that will give us a 7. Well, I'm going to skip this step because we've practiced enough on how to use it. We understand that we need to find the factors of 18. So here's my factor table. 1 and 18, 2 and 9, 3 and 6. From these factors, we're trying to find the ones that will combine to give us a 7 somehow by adding or subtracting them. Well, 6 plus 3 is 9, 2 plus 9 is 11, 1 plus 18 is 19. So adding doesn't work. That's why there's a minus here. It indicates that the two factors need to subtract. So the only two factors that can subtract to give us a 7 is 2 and 9. So that means in our factor, in our parentheses here, we need a 2, we need a 9. If we look at our leading term, x is being squared, so that means that there should be an x here and there should be an x here. Because if we multiply binomials, remember we did that before, x times x will give us that x squared that we need. Now, how in the world can 2 and 9 give us a 7? And it's not just any 7, it is a positive 7. So the only way that could work is either the 2 is a negative, the 2 is a positive, and we're going to add it with a negative 9. Well, if we do that, that results in a negative 7. So that means that the 2 would have to be a negative, and the 9 would have to be the positive, so we can get a positive 7. So we have x is minus, 2 is minus, 9 is plus. Okay, well, we've done that before. We're trying to solve though. So this has to be equal to 0. So we set this equal to 0. Now it's time to set each linear factor equal to 0. So this is x minus 2 equal to 0. And we're going to solve for x. Well, to do that, all we have to do is isolate the variable. Here's my x. How can I get it by itself? Move the 2 over by doing the inverse operation, the opposite. So we move that over. We have that x is a positive 2. So x minus 2, so the 2 is minus there, we move it over and it becomes a positive 2. We do the same thing with the other linear factor. X plus 9, we set it equal to 0 because we're trying to figure out what is this solution going to be. We subtract the 9 over because we're trying to isolate the x, and in doing so we get that x is a negative 9, which makes sense because if 9 was positive here, when you move it across the equal sign, it becomes a negative. So we have that our two solutions here for this quadratic equation, they are 2 and 9. So the way we write them is we use a curly brace and we write our two answers in there. And actually the proper way of writing them is the smallest of the two answers goes first. So in this case the negative 9, because it's a negative value, goes first, and then 2. If you write them the other way around, it's still correct. So this is our answer. Negative 2 and 9 are the two solutions to this quadratic equation. Now there is a way to check if these two solutions are correct, if you did this correct. So what I'm going to do is I'm going to use substitution. So in place of every x, I'm going to substitute the negative 9. So I'm going to substitute it here, and I'm going to substitute it here. Okay, so here we get negative 9 squared is negative 9 times negative 9 is 81. These two multiply to give us a negative 63. Then we have minus 18. When you type all of this into a calculator, you will get 0, and you should get 0, because we're saying that all of this will give us a 0. And again, that's why sometimes instead of the word solution, we use the word 0. Let's check with 2. So since we got a solution of 2, that means we're going to substitute a 2 everywhere we have an x. So a 2 goes there. And I should probably make that a larger 2. And a 2 will go here. And notice I'm always using parentheses for substitution. So 2 squared means 2 times 2, 2 copies of 2. Gives us a 4. Here we have 7 times 2, which is 14. Then we have minus 18. Now 4 plus 14 is 18. 18 minus 18 gives you 0. So this means that 0 is the same thing as 0, which is correct. They're both the same amount. So that's how we know that the two solutions that we got at the end are correct by substitution. Okay, let's try this next example. In order to solve quadratic equations, we can factor. It would be easier to factor. So in this case, we're trying to find the factors of 35. So I'm going to make my factor table, beginning with the smallest one, smallest factor, 1 in 35. 2, 3, 4, 5, and 7. And that's it, because then they repeat again. We're trying to find the factors that will add to give us 12. So the only ones that can add to give us 12 is 5 and 7. So that means we're going to need a 5 here and a 7 here. Looking at our leading term, we have x squared, so we need an x here and x here. How can these two give us a negative 12? If they're both positive, they'll give us a positive 12. So what that means is they both need to be negative, because negative 5 minus 7, or negative 5 plus negative 7, will give us the negative 12 that we need. Now this equation is equal to 0. So once we find our two factors, we can go ahead and set each linear factor equal to 0. That way, we can solve for x. So we're going to add the 5 over, which means x becomes a positive 5. So that's one of the solutions. So we set this other linear factor equal to 0 as well. So x minus 7 is 0. We move the 7 over, and we realize that 0 plus 7 will make the 7 a positive 7. So x will be 7. So we have that our two zeros, our two solutions, I'll use the word zeros, are 5 and 7. And again, to verify if this is correct, all we would have to do is substitute the value that we got in place of x. This next quadratic is different than the two that we were doing. How so? Well, the other, if you notice, the other quadratics were in the form of ax squared plus bx plus c. And actually, a was just 1, so it kind of looked like this here. However, this expression, it looks like x squared term is there, the x term is there. What we don't have is c, the constant term. So we're going to factor in a very unique type of way. If we ignore the 0 and we look at this expression here, we need to figure out, okay, what is the GCF? What do these two terms have in common? Well, if this is a 1, they only have a 1 in common, is what you might be thinking. Yeah, they have a 1 in common, but this has 2 x's, and this term has 1x. What is the maximum amount of x's that I can take away from both terms? To be fair, we can only take 1x away. So that means we're going to factor out an x. So that means from this one, we're going to take away an x. From this one, we're going to take away an x. So we divide by x. So if there's x squared, you take away an x, you're left with x. 24x divided by x, you took away the x, so all you have is the 24. How do you know if they did this correct? Well, quickly. X times x squared, x times negative 24, negative 24x, which matches what we had right there. So really we're undoing the distributive property. Now we're solving. That's why it's equal to 0. So we make this equal to 0. We set up our two linear factors. We have that x, and if you want, you can put it in parentheses so you can see. X is 0. That's it. I mean, there's no solving. It's telling you straight up, x is 0. Next, we have x minus 24 is 0. Remember, we do the inverse. So when we move 24 over, we get that x is a positive 24. So our two solutions here are 0 and 24. And to verify, remember, you can always substitute the two values one at a time in place of the x. Evaluate, and you'll find out that they both give you a 0. Next problem here. Now, if you notice, this problem is very unique. It's different than the other ones. Why? Well, first of all, it is not equal to 0. So that is one rule when we're trying to solve quadratics. They must be equal to 0. So how do we make this equation equal to 0? Well, this 9 looks like it shouldn't be there. It should probably be on the left side of this equation. To move it over, we need to add it because the inverse of subtracting is plus. So I'm going to add it right here because this is a constant term. So the constant term is right behind the x term. So that's why I'm drawing the arrow right there. So we have 2x squared plus 9x. This 9, once it gets moved over, becomes a positive 9. Negative 9 plus 9 is 0, and now it's equal to 0. Okay, so we need a factor. This equation has a leading coefficient that is not 1, it's a 2. So what we do is we use the AC method. And the AC method says you need to multiply A, which is 2, times C, which is 9. So I'm going to set up my two binomials, and we already know that they have to be equal to 0. So 2 times 9 is 18. So I need to find the factors of 18 that will give us a 9. So 1 and 18, 2 and 9, 3 and 6, and that's it. Which ones can add up to give us a 9? Well, if you look through here, 3 and 6. So that means 3 and 6. Since that is a positive 9, that means positive 3, positive 6. Now, since we do have a coefficient that is not 1, a 2, we're going to write a 2x here and a 2x here. We're going to set each, now remember, first of all, if you do a quick check, 2 times 2 is not 2, it's 4. That's not a 4. 3 times 6 is 18. That's not an 18, that's a 9. Well, what we do here is we're going to make one of the binomials smaller by dividing by their GCF, so that here we get x plus 3 is equal to 0. Now we can go ahead and create our linear factors. We set this equal to 0. We solve for x. So in this case, for this one, we're going to have to subtract 3. So 2x is a negative 3. Then we're going to divide by 2. So we get that x is a negative 3 over 2, or you can say that x is negative 1.5. We'll just leave it as a fraction for right now. Now, the other linear factor, when we set it equal to 0, we've already figured out that we're going to subtract the 3 over, and it becomes a negative 3. So our other solution is a negative 3. So our zeros, and I'll write it over here, our zeros, which means our solutions, are negative 3, comma, negative 3 over 2, or negative 3, comma, negative 1.5. And that is our answer. Let's try another example. Again, we have another equation that is not equal to 0. So what we should do is move this term over by doing the inverse, so that way it can be equal to 0. Now, we have a value that is not 1 as our leading coefficient. So we do AC method. This times this will give us a 20. So I'm going to go ahead and do the 2 parentheses and make this equal to 0. So we need factors of 20 that will give us a 12. They add to give us a 12. So the only ones that can somehow give us a 12 are 2 and 9. So that means 2, 9, I'm sorry, 2 and 10. Why did I say 9? 12 is negative, so that means negative 2, negative 10. In each parentheses, we're going to put 4x, 4x. Okay. Now if you forget to reduce each binomial, because this can get smaller and this can get smaller, that's fine. We can go ahead and set up our two linear factors. So here we have 4x minus 2 is equal to 0. We move the 2 over, so 4x is equal to positive 2. And then, of course, to get rid of 4, we divide by 4. So we get that x is 1/2. Because 2 divided by 4 reduces to 1/2. Our next factor here, when we set it equal to 0, we move the 10 over, so that minus 10 becomes a positive 10, and we divide by 4. 10 divided by 4 reduces to a fraction of 5/2. So we get that our solutions are 1/2 and 5/2, or 0.5 comma 2.5. Okay, and we come to our last problem. Here we have a problem that says a rectangle has a length of w and a width of w minus 7. So I'm going to draw a rectangle. The length is w and the width is w minus 7. The area is 18, so the area is 18 inches squared. What would be the dimensions of the rectangle? So you got to remember that in order to find the area or anything that has to do with area of a rectangle, they're talking about length times width. So here we have a length that is w, a width that is w minus 7, and the area is 18. Now, this has to be a quadratic equation, which means we're going to have to multiply here. So this will give us a w squared minus 7w, bring down to 18. Now this problem looks like the ones that we've been doing before. All we have to do is move that 18 over. I'm going to throw it to the very end, because in order for us to solve, this equation has to be equal to 0. So there you go, now it is. Next step, find the factors. That will give us a 0. So we're trying to find the factors of 18. So 1 and 18, 2 and 9, 3 and 6. Out of these two factors, which ones will subtract to give us a 7? 2 and 9. So that means 2 and 9. We look at our leading term, and we notice there's just a w, so w here, w here. Now that's a negative 7, which means the 9 will have to be the negative, and the 2 will have to be the positive. Set up our two linear factors, and we have w plus 2 is 0, move the 2 over, w is negative 2. Over here we have w minus 9 is 0, move the 9 over, and that becomes a positive 9. Now this word problem is asking what are the dimensions. We're talking about the length of something. Out of the two answers that we got, only one of them is valid. W is equal to 9. This one is not valid because that is a negative value. And if W is negative 2, we're saying that this side is negative 2 inches. That doesn't exist. We cannot have negative lengths. So we're going to go with this value. W is 9. So we're saying that W is 9, and you got to remember, well, they said the length was W. Well, we just found out that W is 9, so the length is 9 inches. The width, they said, is W minus 7. Well, since we found W, we know that W is 9. 9 minus 7 is 2. So this is 2 inches. So the lengths are 9 inches by 2 inches. And that is how we solve this problem here. Thank you for watching.